So here we have a Boolean function with 3 variables, and we have its list of min terms, and we're supposed to list all of its prime implicants and identify which of these prime implicants are essential. So the first thing we want to do is make a K-map, and so to make a K-map, a 3-variable K-map, we'll have 2 rows and 4 columns. And I'll put RS up here and T there. It doesn't matter what variables you put where. Just for fun, look at my screen. And now look up there. Do you see a difference?
No.
Do you see the...
Oh, it's green. Green is on yours.
Yes.
Okay.
Is there a reason for that?
I don't know.
That
Okay.
is weird.
Okay, so if you have the variables in a different place, then your K-map won't look the same as someone else's, but your results should be the same. Now, you do need to have 0, 0, 0, 1, 1, 1, 1, 0, and it does need to be in that order. Well, you could have it in the backwards order, but don't do that. And then 0, 1. And then, when it's given to you as a sum of min terms, then it's easiest just to remember that these squares correspond, so it goes 0, 1, 2, 3, and then it skips to the end, 4, 5, 6, 7. And the reason for that is, notice that the number 0, 0, that's the binary number 0, 0, 1 is 1, 1, 0 is 2, and 1, 1 is 3. So it goes in order 0, 1, 2, 3 to label them. If you go online and look at worksheets that I have put up for some of the previous sessions, I have some pages in there that have this already done for you. So if you wanted to, you print that out and have it when it's time for the test, so you don't have to remember, or you don't have to like worry, oh, did I get it wrong? You could have those handy. And then, so having this as the sum of min terms, so it means I'd have a 1 here and a 1 here. Everywhere where I've got a min term, that would be a 1. And 5 and 7. And a prime, well, first of all, an implicant is any circle that I could make. So, so I could have 1 or 2 or 4 or 8. It could contain that many. And let's see, to make sure I'm remembering correctly. Yes. So anyone that is legal is going to count. So I could have this one, and I could have this one, and I could have this one, and I could have this one, yeah. How did he get the ones that he has?
So is an implicant just any possible circle?
Not just any possible circle. Oh, I was misreading it. So it's any possible circle that is not included in some other circle. So because this says prime implicant. So an implicant would be any legal circle. So that's an implicant, and that's an implicant, and that's an implicant. Those are all possible implicants, but they're not prime implicants because they're contained inside another circle.
Interesting.
So that's the difference between implicant and prime implicant. And we'll do another example after we finish this one to practice with 4 variables.
So,
So there's only one prime implicant in this?
Nope, nope, there's going to be more than that, so I
There's
can't.
5.
Well, there are 5 prime implicants.
Oh.
So is it 5 or is it 4? It's 4. So this first one right here
Okay.
is, let me do this color, this first one right there is R is 0 and T is 0, so that's R bar, T bar. And the next one would be this one. And for that one, R is 0 and S is 0, so that's R bar, S bar. And then for this one, that has S0 and T1. And this one has R1 and T1. So those are our prime implicants because they are not completely contained in any other implicant. To make sure I got that right. I don't know why I can't remember something from one screen to the next, so I'll just pretend that it's right. Let's see. RT, R bar, T bar, R bar, S bar, RT, yeah, okay, that looks right. All right. So now these are all prime implicants because they're not contained in any other implicant. So these are all prime implicants. If I had to list all the implicants, and I have seen him ask this on the test before, so if you had to list all the implicants, you would also, the only other implicants this has are the ones that are just the circles for the single ones. And so those would be like this one up here would be, so implicant that's not prime would be R bar, S bar, T bar, or R bar, S, T bar, or it's basically all of these right here. R bar, S bar, T.
I can't really read the new handwriting.
Huh.
It's very faint. I can see it there, but it's very faint.
I actually do know what the problem is because I used to teach with the projector and not the screen, so I do know how to fix this. Although it took me a year to figure it out.
What was the problem?
This cable, it's not a big cable, but there is another cable. There's 2 cables attached. Unless they've changed it, because I have not used these cables. So I don't really know what the problem is, but I do know how to fix it. And I do know that the problem exists in that cable, and I suspect it's that there's a pin that's bent or something. Oh, that's not much better. That's a little better.
That's a non-prime. These 2
And you can't cross mark one. It's so sad.
Well, you can legally. So like, legally this is okay, but this one and this one are prime because they're only in one circle.
Can y'all deal with that?
Yeah,
Okay.
that's fine.
Okay, so let me redraw this, and I'll, because now you can't see. Does the green show up?
Yes.
Yeah, they're showing up great.
What's more blue?
That's because I spent, well, I don't know if it's still set that way, but I spent quite some time trying to adjust the colors on this to make it visible on there. The fact that the other one was visible at all was took a lot of work. So I'll put ones in all of these, 5, 7, 0, 1, 2, 5, 7. Okay, so your prime implicants are the ones that we're used to looking for, as big as possible, and a multiple of 1. It either has a power of 2. It has 2 to the 0 or 1, or 2 to the 1, 2, or 2 squared, 4, 2 to the 4, 8, 2 to the third, 8. And it can't be completely contained in any other implicant in order to be a prime implicant. And actually, nope, none of those are completely contained in any other implicant. It can be partly contained in one and partly contained in the other, but it's not inside of any one. And so these are all our prime implicants, and they were R bar, T bar, R bar, S bar, R, T, and S bar, T.
So, for example, if we had a row of 4,
Yes?
that would mean that there's not only and
Yeah. We'll look.
Okay.
Let's do this one, and then I'll show you what it would be like. Okay. Each one of those is an implicant because they're legal. It's legal if it has 1, 2, 4, 8, or 16, and they form a square, a rectangle, they're all adjoining. And so all of those are legal, but none of them are prime because all of them are completely contained within some other implicant. And so these are not prime implicants. And we still haven't done the essential ones yet, so not prime implicants.
so there's 0 prime implicants.
No, there are 4 prime implicants. None of these are completely contained,
And that makes them prime.
and that makes them prime.
Okay.
Because I think this will make sense when I do another one that has more.
Okay.
So the not prime implicants are R bar, S bar, T bar, R bar, S, T bar, R bar, S bar, T, R, S, T, and R, S bar, T. It's basically all of those min terms. Now, we haven't done the essential implicants. The essential implicants are the ones that in any K-map that covers all of the ones, it has to be there. So, for instance, is S bar T, this one, is that one essential?
Yeah. Oh, no.
No, because if I didn't have that one, would I still have all the ones covered?
Yes.
So if I had just these, I would still have all the ones covered.
Okay.
Okay, so that one is not essential. Are the 3 that I have left, are they essential? And I believe they are. So it's essential if it contains at least one that is not contained in any other essential implicant.
So it has to be essential.
Right, because if you look at this one right here, you'd say, well, this one's contained in this one, and this one's contained in this one, but this one is non-essential, so if I take it out, it's not contained in any other.
Okay.
In a typical K-map that we draw, are all of them essential? Because we try not to draw more than we need to.
Yes, that is correct. In the K-maps that you draw, they are all essential, because that's what gets you the simplest expression, because when you have all essential, then that gets you, and sometimes there's more than one way to do it, but this is going to get us the most simple expression. So now let's answer the question that you were asking. So what if I had the sum, let's do, just for fun, let's do max terms. And let's say I had 0, 1, 2, 4, 5, 7. Now, if you had to do this one, it'd be a lot easier to do it as min terms, because as min terms, it'd be just 3.
And 6 too.
Right. But we're going to do it as max terms for fun. And just to make things different, I'll do A, B, and C. So, and it's the dual. So rather than putting 1s in, I put 0s in. All right, so does anybody see? Why don't y'all write this down and try to get the prime implicants yourself? See if you can figure out the prime implicants, and then we'll check and see if we all got the same thing. So that's all of this. I only get 3 prime implicants, and I have that they're all essential.
Are there a few different ways you could, I suppose, get your answer depending? I guess I'm not sure how to word it.
Sometimes that is true, and this one I don't think it is. Did you get just 3?
I got 4.
Yeah,
but
so mine, so that means that something that you have is actually not prime. And I bet I know, did y'all get this one?
Oh,
I forgot to
no.
get
Yep.
That's my bad.
And so what you want to be aware of that, especially when you have a 4-variable Carnot map, because the 4 corners count, And those show up on tests about once every 3 semesters. There's one on a test with 4 corners, and people always don't see it. So there's that one. So if you had said this was a prime implicant, that would be wrong because that's completely contained in the other one. So
and then the other two, they're just by themselves.
nope,
Or yeah.
they're like that. So I got that the 3 prime implicants are B bar, A, and B bar, comma, that's the big one, AC and A bar, AC. Oh, no, because we're doing max terms, that would be B plus A bar, no, B times A bar plus C bar times A plus C.
Wouldn't A bar plus C bar times A plus C like kind of cancel out?
Yes. Now, why would that be? Because this is the minimum. Well, they don't completely cancel out, but this is the minimum product of sums. It doesn't mean it's the lowest cost, because what if I forgot, I said you could do it with just, there were actually two min terms in there. So if we did the min terms, they're very small circles, but there's only 2 of them. So the min terms are A bar B C plus A B C bar. So if I multiplied this out, I would get B A bar B plus B C bar plus A C bar plus, wait, I'm messing up. I would get A bar B plus B C bar, that's multiplying the B through there, times A plus C, and then this multiplication gives me 0. This multiplication gives me A bar B C. This multiplication gives me A B C bar, and this multiplication gives me 0, and that should be the same as what I got over there. And so parts of it canceled out. So if I had done this multiplication first, here, this times this cancels, but this times this does not, A bar C, and then plus C bar A times B. So I have B times A bar C plus AC bar. Now, just for fun, how many gates and how many inputs into those gates do I use for this? What do I need to make that?
You need 3 gates. You need 2 AND gates. Yeah,
two 3 input AND gates.
And then, 1, 2 input, 4 gates.
Right. And did y'all learn to do the cost by the number of gates plus the number of inputs into those gates, or have y'all not talked about cost yet? Okay. So this would be 2 plus 6 plus 1 plus 2, if I did that right. So it's 9 plus 2 is 11. Okay, and how many gates do I need for this one up here? And let's not count the knots.
You need 3 AND gates.
I need just one 3 input AND gate. I knew what you meant. And what else?
2 OR gates with both 2 inputs.
2 input OR gates.
And 2
And sometimes you count knots and sometimes you don't. I didn't count the knots over here, so I won't count them here. So, but it would be this, and it would be the same on either one. You wouldn't need more knot gates on one than the other. So this is 1 plus 3 plus 2 plus 4. So that's 4 plus 6, that's 10. So this one, while it seemed like it was going to be harder to make, is actually lower cost. But, do y'all know what this is?
It's the lowest. Wow.
That's exclusive OR. So think about an exclusive OR. If I have A and B, and A exclusive OR B. Do y'all know what exclusive OR means?
It's an odd number.
Right. And so it's OR, so we normally say it's OR if as long as you have one. But exclusive OR means it's either this one or this one, but not both of them. And so this has the table, so that gets you a 0, and this is a 1, and this is a 1, and this is a 0. And this is A B bar plus B A bar. So whenever you have that, that's an exclusive OR. So this is the same as saying B and the exclusive OR A bar C exclusive OR AC bar. So what do I need here? I need 1 2-input OR gate, 2-input exclusive OR gate, 3 2-input AND gates. Because it would look like and so I have 3 2-input AND gates and 1 2-input exclusive OR. So that would be 1 plus 2 plus 3 plus 6. Ah, shoot, I thought that would be easier. I thought I was so clever. I did. Oh well. So let's get the definitions of these things. So what is an implicant? So an implicant is a group of 2 to the n ones for min terms, or zeros for max terms. I know, isn't that nice? That are contiguous. I don't know if that's a good word. They have to be touching either another cell, either going up or down or right or left. They can't be touching just just diagonally. Like for instance, this is not an implicant. So, because the way the K-map is designed is that the things that are adjacent either horizontally or vertically share a variable. So that's an implicant. A prime implicant is not completely contained within another implicant. So that's a prime implicant. And then an essential implicant, the official definition, you want to say that an essential implicant has to be in a minimum cover, but that's not entirely true, because essential doesn't exactly mean essential, and I'll show you why in a minute. So has at least one, not contained it's time for me to stop because my pen's lagging, and another essential implicant. So the essential implicants up here were, let's see if you got them. This one. So we did get that one. What else did y'all get?
The center horizontal one on 7 and 15.
7 and 15, correct? So this one.
And then 14 and 10.
And 14 and 10. Now notice this vertical one here, that the 15 is contained in the horizontal one and the 14 is contained in the other horizontal one. So that one is not essential. So now I want to show you one that surprised me the first time I saw it, if I can remember how it goes. That's not it. Yeah, okay, so look at this one. So say this is X, Y, Z, W. And I want all of you to come up with what you think is the minimum cover for this one.
By minimum cover, you mean?
Fewest number of circles with most number of things in the circles. You're
I like
basically
that
you're using the Carnot map for the right reasons.
All right. I like that definition. It was a very, like.
Yeah, it's what you have to do.
Yeah.
Yeah.
Very direct.
I've been doing this for so long, I forgot that wasn't the normal definition.
It's like my monkey brain can comprehend that.
And it's not really a trick, but it's kind of a trick. I mean, there's more than one right answer. Which is what that's the point I'm trying to make. So does anyone want to tell which one they came up with or which ones they came up with?
I got at the top
Mm-hmm.
a horizontal,
Mm-hmm.
and then again horizontal with the bottom, or yeah, with the middle,
Mm-hmm.
and then a vertical.
Okay. Perfectly okay. Anybody come up with anything different?
For that middle horizontal one,
Uh-huh.
I did it so that it was the one stacked on top.
Like that?
Yes, yes. And then the rest was the same.
So you did that and that.
Yes.
Uh-huh. And I think those are the two ways to do them. I don't think there's another way. But notice, this has 3 groups of 2 and this has 3 groups of 2. And they're all legal. Is would you define all, so let's see, which ones are the same? So this one is the same, and this one is the same, but we have a horizontal one here and a vertical one here. Are they both essential?
Yes.
Yeah, by definition, they're both essential, but that's not really our everyday meaning of essential. You know, it's like you would think essential means you have to have it in your Carnot map. You have to have one of them.
You just pick and choose, or is
Yeah, you
it-
just pick and choose. It's and you'll see if you look at solutions. Sometimes there'll be a solution. They'll say this or this, and they're both correct.
But it wouldn't be correct in saying all in all they're both essential at the same time.
No. If you had to list the essential implicants, you should list both of them.
Both?
If the question said, what are the essential implicants? Yes, you list both of them. But if it asks you to use the Carnot map to come up with a minimum sum of products, you don't use both of them. You just choose one of these and go with it.
Okay.
All right, I think I am 5 minutes over. So
I gotta get a haircut anyway.